This question, it shows ray diagram for an object placed in front of diverging lens. If it's not written it's diverging lens, we have to know without even mentioning, because we have many evidence to represent this. Number one, the shape of the lens. Number two, the refracted rays here. As we can notice that rays will refract away from each other, will refract outward, will be separated away from each other. So for image produced by a diverging lens, they all have same properties. We consider that we have same case, because if object is placed in front of diverging lens, all the time image formed has to be number one, virtual. Since it's virtual, which means upright, erect, upright. It's not inverted, it's not upside down, and it is always smaller in size. If you remember, in case of magnifying lens, in case of convex, the only case the image, virtual image is formed, this virtual image will be enlarged, bigger in size. You don't ever get confused. But in convex, in concave, the image is always smaller in size. So going back to this question, so real? No way, it's not real. Before even reading the rest, you eliminate these answers because no way to be real, so it's virtual, either C or D. Larger? No, it's not larger, it's always smaller in size, always smaller in size, so option D is correct. An object is viewed through a concave lens. What is the correct description of image formed? So for concave, again, concave. So we agreed it's always virtual, upright, smaller. Going back here. Again, we are going to eliminate answers. A and B will be cancelled. So either virtual, inverted, magnified, or virtual upright, diminished. For virtual, no way to be inverted. These two properties, no way to come together. So it's virtual, true. It's upright. It's diminished, which is smaller in size, so D. This shows drawing. You need to draw. That's why please make sure to bring a ruler to make your drawing accurate, so you won't lose marks. Number two, you need to follow correct rules. You don't need to draw 3 rays unless the question asks you to draw 3 rays. Yes, for similar to this question, it's written in a clear way. Draw 3 rays to locate the image. So this means you have to draw 3 of them. Again, following our rules. Number 1, light falls parallel, refracts passing through F. Number 1. Number 2, passing through focal point, refract parallel. 3, which is the easiest, that has to pass through the center of the lens and complete its path straight. So all refracted rays will meet at a specific point. This is the point where the image will be located. While drawing, please, you don't forget, you have to draw a dashed line or a line, it's okay. You draw a line, but you need to show where is the head of the arrow. This is very important, because if the head is drawn up, that means It's upright. So marks will be deducted. You're gonna lose mark here. So that's why I'm asking you, please, you need to be accurate. You draw it with head down. This shows it's inverted. This means it's real. So 3 properties. Number 1, real. Number 2, inverted, or you can replace it by writing upside down. Number 3, enlarge, or you can replace it by writing bigger in size. State how the image produced by magnifying glass is different. To remind you, what is the magnifying glass? Magnifying glass, if object is placed in front of the lens or inside focal point. So let's consider if the object is placed here. In this case, the image will be located at the same side. Here will be located here, and it will be virtual. So the question doesn't ask about drawing, asks about just compare, differentiate between properties of magnifying lens and properties of this case. So number 1, the image produced has to be upright. Since it's upright means virtual, you don't forget also to mention it's enlarged or bigger in size. The student moves the object O to a position P. Let me just erase this to be able to read. So that the lens show in figure. Since you place it, since the student place it at position O, this shows magnifying. Mark a possible position for P. If object is placed here, mainly the image will be represented at the back side, which has to be enlarged. I think no more questions related to lens. Oh, we have one more question. The diagram in the figure below shows one ray in this type of lens. What type of lens is this? It's convex. Convex, automatically you connect it to ray will be refracted inward. Okay, so on the figure, use the ruler to draw another ray from the top of the object. Okay, so if we need to draw another ray, it's up to you. Either to use the rule that it passes through the center of the lens, so it will move straight, or it passes through focal point, then will refract, passing parallel to the principal axis. And of course you need to identify the location of the image. The meeting point of refracted ray is where the image will be formed. Here describe the properties. Which of these properties will be correct? Much larger than the object? No, it's not. Much smaller? No, same in size. Yes. Of course, as I used to tell you, before going to answer a question, you have to predict your answer. Obviously, this is focal length, and this object is placed at a distance which is double the distance of focal length. So this means image has to be equal in size, same distance away from the lens. It's upright? No. It's inverted? Yes. It's real? Correct. The object is moved to a position further from the lens. What differences are seen in the image formed here if by placing this object further away from the lens? So what are you expecting? We said when object is getting further apart, object is getting closer and smaller in size. So it gets smaller in size. So it gets closer to the lens and smaller in size. So the answer has to be here. I'm sorry. So closer and smaller in size. Okay. Now, going to the last question here that talks about calculation and formula used. Before we get started here, I need to remind you, in case of lenses, based on the type of lens, we are going to identify whether these length will be positive or negative. All lengths are measured by either centimeter or meter. We don't care about converting units, but the main important thing is the sign of the length. For convex lenses, focal length has to be positive. Of course, the object in both lenses has to be opposite. No doubt of this. For the image could be, for the image length, image distance, could be positive or negative. When exactly will be positive? If it's real. When exactly will be negative? It's virtual. This means all cases of convex will be positive except of magnifying lens. If it's very close to the lens or in a distance smaller than the focal length. Let's go to understand more. Let's solve this question. Okay. 2 centimeter tall. We don't care about the height or the tall of the object. So this will not be used. Is placed 10 centimeter from convex lens. If you'd like just to draw, to just visualize it, the situation will be much more easier. So a small drawing here. This is our lens, focal point. So in convex, the object is placed 10 centimeter and the focal length is 20. So if focal length is 20 and the object is placed at distance of 10, what does it mean? You need to predict your answer before even calculating, which means that number 1, image has to be magnified. We don't care about height. Has to be virtual. Since it's virtual, so it has to have a negative sign. Now, let's go to apply the formula. Our formula is 1 over f is equal to 1 over u plus 1 over v. What is f? F shows focal length. U shows object distance, v for the image. Going to substitute 1 over f. Focal length is 20 and convex, so it's positive 20. We can replace it just 1 over x. What is the object distance? 1 over 10. So shift solve. You don't need to use math calculation, or if you don't mind, it's okay, but the main important thing, you make sure that you're gonna get a correct answer. So x is gonna be equal to negative 20 centimeter. As we agreed earlier, you don't need to convert units since all of them with centimeter, keep it centimeter.